Right now, quality is the next one they want to talk to. This is, I argue a little bit with myself about whether this is actually different from scope, because when you really define your scope, what you're telling your customer is what will be included and what will be there, and typically your quality should be a part of that scope. So it'll do this thing a certain amount of the time. It'll do this, 100% of the time. That's what you should expect. But it's basically broken out as a separate phase because the processes that you run are a little bit different. Quality is directly proportional to project cost. And the thing we're going to focus on in this presentation here today, and again, I'm not going to go over all the charts. I want you to spend some time doing that. But there are some key messages, and what I really want to focus on is the relationship between cost and quality, meaning there is a myth associated with if you spend too much time, building quality in, then it's going to overrun your cost. The reality of technology projects have proven over the years, over the decades, and especially in recent times, that the more time you spend uptime making sure it's right up front, the less it costs to actually complete the project, and the more likely the thing will actually work when you want it to work. So we'll talk about that. We'll talk about quality phases and other knowledge areas associated with it. It's your quality guy on the right. He's looking at you suspiciously because he doesn't think you're doing a great job. Let's keep in mind what quality really is. So quality is really conformance to requirements. So what processes and products, are they meeting the written specifications, and are they fit for use? Right? Can it be used? Can the product be used the way it was intended? If it can be used, just anything you buy at home, if you can use it the way you intended to use it, then you consider it to be good quality. Right? If it continues to do that over time, you consider it as good quality. It's not the same as a grade, okay? There may be a low grade capability or product, but it just needs to meet the expectations that you have for it. Components of project quality are user satisfaction, prevention versus correction, right? The biggest benefit of quality process is bringing the project, continuing the project moving forward. Continuous improvement, so philosophy that improved quality is always better and that we can always improve on what we're doing. There's no standing still, right, in this technology development. You're either getting better or you're getting worse. So you focus on your quality so that you can get better. Continuous improvement. And then management commitment. The willingness to forego immediate benefits for longer term benefits. The willingness to say it's not done until we know it's done right, and then move on. Which may mean some short-term schedule problems. It may mean you have to apply some management reserves to get yourself back on track early. But that saves you a lot of effort down the road, which we'll talk about. Is the ability to anticipate situations and prepare for actions to bring the desired outcome. It's a lot about preventing defects, okay? Selecting proper materials, training people appropriately, making sure that the processes are in place that will ensure that you get the appropriate outcome as you start to develop this capability or this product that you're developing. The technology project management has to include quality. So you establish leadership that promotes quality up front. That's your job. Understand the cost of quality, okay, and what that means to your project down the road. So another one of these examples where experienced project managers tend to do better because they know the cost of not building quality in up front. Cost of conformance, cost of non-conformance. I mean, there's a cost to delivering products that meet requirements and fit for use, right? That's the cost of the project. Cost of non-conformance means every cost that you entail because you didn't do it right, and you have to go back and rework the whole thing. You need to put a lot of focus on the organizational influences, because if that's the way projects have been run in the past, that's kind of what your people are going to be expecting in this one too. And you need to break that mold. Quality management ensures that the project is going to satisfy the needs that was undertaken. So there's a number of processes that your book goes through. Quality planning. We'll talk about that. We'll develop a quality plan for the project management plan that you've got in place. Quality assurance and control of the processes and the elements that you're going to put into place as part of that plan that will evaluate overall project performance and results. And then the core qualities of project success or failure are functionality, making sure it's got the features correct, making sure you get the system outputs that are supposed to be generated. The performance is good, reliability is good, and it's maintainable. Okay, all of those are elements of quality. So quality defined by your requirements, basically what we're going to look at are, there's functional requirements, which are, how well does it perform, what's the speed, what reports are generated, technical requirements in terms of the hardware, the software, all those kinds of requirements. But the acceptance criteria are the key things that are going to trigger acceptance of the product. So does it form, fit, and function the way the user expects? Does it work continuously? Is it super fragile because we didn't make it, objectified enough to handle changes in the operating system? All of those things in terms of maintenance and all that kind of stuff, is it acceptable based on the way it is? Quality metrics then feed those. They're measurable. They're used in development and testing. We'll talk a little bit about that. 5 categories of cost related to quality. Prevention cost, the cost of planning and executing the project so it's error-free or within at least the acceptable error range. That should be baked into your project. Appraisal cost, that's cost associated with the actual process of evaluating the outputs to ensure their quality. Internal failure cost is a cost that's incurred to correct and identify defect before the customer receives the product. External failure cost is a cost incurred after you've delivered it, and they come back and say this isn't working. Now you got to gin up the whole project again to get something fixed. We're going to talk about the differences between those costs. But this is basically what we're talking about. So if you look on the left here, then the cost to correct a bug is basically, if you correct it in design, you just spend the time fixing the design. No big deal, right? It's 1 times the cost to actually to fix it. If you get into development, now you got to go back and potentially, when you change in development because you realize there's an error, you got to potentially change design. That might have some impacts. That's going to be 5 times the cost of actually finding it up front. When you're doing unit testing, that means all the code has been done. It's been checked in. Now you've got a unit test that shows a problem. You've got to go back, correct the code, potentially change the requirements, potentially change the design. If you wait until integration testing, when you're integrating all the different components, now you got to go back to multiple different programmers that probably have to change stuff, multiple different designs. You're talking about 30 times. And if you release to the customer and actually goes to the help desk, you got to gin up the whole project to get something fixed. It's a huge cost to the project. The reality is, what you see here, a lot of these problems are getting caught here. And this is the bulk of where stuff gets caught. That's a big mistake. You want to have all of your problems caught up here. And a little bit of investment up here to really try to find those problems before they go downstream is a huge savings, both in terms of time and cost to the project. That's why monitoring quality is so important. You have status reporting on metrics, you do issue tracking, change management is in place. And I'm not going to go through all these different tools of quality, but I want you to spend some time on each one of these just to know these are out there, and these are mechanisms that you can use to sort of track quality. Cause and effect, or to help you figure out where a quality problem might exist. Cause-effect diagrams. Basically, when you have a problem, how do you figure out what actually caused it? It's use these fishbone diagrams, but essentially it's the 5 why rule. You keep asking why something happened until you get back to the actual root of the problem. Why did this fail? Because it was coded wrong. Right? Why was it coded wrong? Because the requirements said, because the programmer read the requirements directly. Why were the requirements wrong? Because this interpretation, you could keep going all the way back until you find what the actual problem is. Then you fix that and let that cascade back out. Quality control charts. This is graphical. Can be useful if you're doing a lot of the same kinds of things over time. So if you have a lot of development that's in a zone and you can measure products, let's say. So this is great for like chips, things like that, where you measure a certain value of that chip output over time. If they go out of these tolerances a little bit, maybe you don't think there's a problem with the process. 7-run rule says if you stay outside of a tolerance for a period of 7 runs, then you've got a problem with the process. You need to examine what's going on. Run charts, same kind of thing. Value charts, those data points plotted in the time they occurred, can be used to do trend analysis, basically, and forecast future outcomes based on historical patterns. Different kinds of ways to look at quality problems as you move forward. Scatter diagrams, this gets into data analytics a little bit, where you start looking at if there's a relationship between 2 variables. Closer data points are to a diagonal line, the more closely these 2 variables are going to be related. That may lead you to some idea of, you can do this across your development to say if it's time associated with particular modules, or if it's how much time was spent in code, or if it's particular developers and particular numbers of unit test problems. That gives you an ability to go say, look, I need to target this developer, give them a little training on this, or make sure that they're doing this particular process differently. Histograms, another way just to look at the distribution of variables. Each bar is an attribute or characteristic of a problem. You can kind of see what the frequencies are. What we're talking about here is understanding your errors and things that are problems that are happening, and being able to go and track them, identify what the actual root cause of a problem is. The Pareto chart is a little bit different. In fact, it helps you to categorize your problem areas. It goes back to the sort of the 80-20 rule, meaning 80% of problems are often due to 20% of the causes. If you look, this is like compiling software, right? The first couple of errors that you fix in the compiler gets rid of a whole bunch of, in the compilation process, gets rid of a whole bunch of errors, right? If you find those key areas to focus on, right, then you can start actually improving the quality much more tremendously than if you just focus on the smallest problems. So it's an idea of, let's find the biggest problems up front and work those, and then continually look at it again. What's the next biggest problem? And start working those. That way you get to the vast majority of the issues. Flowcharts are just another way to look at, how do you, if you take a start and you go to actions and then decisions that get made from those actions, you can logic and flow out activities and understand how you got in a position where there may be an error that's occurring. And then from that, you can figure out how you can get back out of it. Statistical analysis, sampling, this can be very useful for taking, you see, you can't always necessarily test every single element of the program, so you want to do some statistical testing up here. And if you pick certain areas and you start to see that there is actually a problem in a particular area, or more than you'd expect, then maybe you break that code out and say, all right, let's take a little deeper dive into this thing and make sure we're getting a pretty good product coming out of this. DMAIC is really just a definition of a closed loop continuous improvement environment. Define, measure, analyze, improve, control. This is how we should approach the product quality itself and make sure we're kind of cycling through this process so that we're continuously improving how we're doing projects. Your continuous improvement process should have an element of it where we look at it and we say, this is what we're doing on a weekly basis. How are we getting better? Every week you should be trying to do something a little bit better than you did the week before. Some of this gets into the agile development environment, which we're not going to go into a whole lot in this class, but basically it's the notion that you can always get better, and as you get better in development, your quality gets better, the cost for decreases, the actual speed to development increases. 6 nines is really a big target that they shoot at for quality when you're dealing with things like telecommunications industry. If we're dealing with keeping these servers up for a long period of time, or those kinds of things, we want to put targets out there like 6 nines that basically says it's a target goal for a number of errors, and we try to keep going until we get to the point where we can get down to the 6 nines percentage of errors. Testing. The last thing we're going to talk about is testing. Testing is done in every phase of the product development life cycle. Okay? You don't think, it used to be you thought about coding and then testing. In reality is now it's, this is what I just did I do it right? You're always asking that and making sure that the quality is there at the unit level, at the integration level, at the system level, and when the user accepts it. So different kind of testing that we're talking about here. The unit tests happen for each component. They can be programmed directly into the software as you go. Integration testing, when you integrate those together. System testing means you can test the whole thing, and user acceptance is what the user actually says before it's delivered. Continual testing is important. It keeps costs in line. Go back to that quality chart. If you're testing up front, you're getting a lot of problems fixed early on, long before they become 100 times the cost. Okay? If you're not continually testing, it's like not filling your gas tank. You can ignore it. Everything will seem fine until all of a sudden it isn't fine. So that's what we need to be thinking about. Each of these charts here, I'm going over these a little bit, kind of backwards here. Deliverable testing basically means usability. Is it robust? Does it hold up to what we expect? Does it flow right? Acceptance testing, does it meet what we needed? One way to get out in front of that's beta testing, right? You think you've got something that works, beta it. Put it out there in front of a few users. Make sure they have opportunity to document issues and bugs and stuff. Use it as a dress rehearsal. So it's not completely all buttoned up, but it gives you an opportunity to test it before the team is done with it, right? It's the ultimate integration test. But continual testing is what we're looking for. Unit testing, as each piece is developed, make sure it meets the specifications. Get to integration testing then, when you put them together, make sure they interface appropriately. Regression testing means when you introduce a change, go back, retest the stuff that was infected by it, and see if you see any changes along those. Regression tests should test any changes to the platform. Performance testing is really about stress, load, and reliability. And then our discrete tests, right? Benchmark tests where you go in and see if they meet some standards, pass, fail. Security testing is done, based on your security regimen. So those are the elements of testing. Continuous improvement ought to be an element of your project from the get-go. Make sure we're building quality in from the start.